So before I do the actual lesson, I'm just going to talk a little bit about how the class will work, like what we'll do each week. So the first week is going to be based on probabilities. So there's counting with combinations, permutations, just general probabilities, and then a little bit of statistics with like means and averages. And the main focus that I want to do with every week is correlate each concept to actual AMC 8 problems. So most of the kids, especially when I saw the answers to the mock trial and like what they wanted from the class, it's mainly focused on how do I do well on the exam, right? They're young kids, but they still have like good aspirations. They want to do good on the AMC 8. So when I'm teaching the concepts, rather than focusing on basic, okay, this is what a combination is, or this is how you solve combinations, it's like, how will this actually appear in a problem? And how can you use what you know and maybe what you even don't know to figure out a way to solve a problem? So a lot of these AMC 8 problems and competition problems in general won't, like the terminology that they'll use will be unspecific just so that they can throw off whoever's competing. And just understanding what specific words and what different terminology will mean when it comes to, for example, combinations or permutations. And the second week is geometry, which I think is definitely one of the more difficult, probably the most difficult week. Geometry, especially for younger kids, is a little bit hard to understand. So over the 5 days, we're going to do 3 geometry, polygons, triangles, squares and areas, and then just miscellaneous other geometries that you'll see. Geometry is definitely the most difficult one. I think we're just definitely spend a lot of time on that because especially at a young age, understanding just shapes, and especially in AMC 8, they'll throw in like heptagons and nonagons that really don't make sense unless you really understand what the shape is and how to break it down into simpler ways. So that's definitely going to be a big focus on understanding those complex problems when you get, especially in the AMC 8, through the last 8 or so problems. There'll be a lot of complex geometry, and just breaking it down first into a simpler way to solve those problems is definitely important. And then week 3 is going to be algebra. So that's just going to be everything else in AMC. So algebra and miscellaneous is what I called it in the one on the website, but basically that's everything else that you'll need to solve any of the problems. So it could be from learning like how do you simplify multiplication, how do you take a situation that has both geometry and probability and put them together. So a lot of things, especially with complex geometry, is going to involve both combinations or like different ways you can arrange shapes and then putting those all together algebraically or solving algebraic expressions, quadratics, whatnot. That's all going to be part of the AMC, and it's very important that kids understand that. So that last week is kind of built in as a miscellaneous wrapping up of whatever wasn't covered, and that's when it's going to get to the most difficult problems on the AMC. And I'll really explain to kids how would you break this down, and even if like problem 23 seems really difficult, you can break it down into smaller steps and then it's going to be easier to solve. So that's more of a problem solving aspect. All right, now I guess I'll move into how a regular lesson would be.
Yeah,
So
before you start, are you Ashuath?
Yeah, I'm Ashuath, sorry.
Cool.
So we can go. Yeah, you will be worth reading with here today, but I don't think he's here. Oh, and Ian Ray will come a couple days when I can't make it. So he's just like a guest speaker. So the first day will be counting and combinations, and I'd start with a little warm up, like gauge how much people know, or like if their kids were here, I'd say like, what is a combination? Can you pick 3 of these 5 balls? What is a one possible combination? And I'd wait for answers and whatnot, and then I'd start going into explaining what specifically a combination is. Because in AMC 8, they have very specific rules between what is a combination versus what is a permutation. And the main point is that a combination does not need order. So if you ask for a combination of 3 balls, ABC and BAC are the same combination. And that's kind of the main point I want to focus on. Like on the actual lesson, I could bring in a couple different colors of balls or shapes or whatever so that they can actually try to experience what it is to make a unique combination. And my focus on this is just going to be how can I make kids understand, okay, this is a combination, this is a permutation. We're focusing on combinations. So, and then I would go into like, how many different ways can you pick 3? And for this, if you don't understand combinations, what a main thing is just write out every possible combination. So ABC, ABD, ABE, whatever. And that's the way kids will first learn what is a combination? How do I figure out a combination from a group? And then once they're done with that, they'll list them out, list all of them, count them up, and they'll figure out kind of patterns along the way. So if they do ABC, ABD, ABE, they'll be like, oh, I can just pick 2, and then the remaining, I know there's only gonna be 3 other options for the third ball. And with that, that kind of leads more into this kind of a problem, which is a direct way of how do I just take the information I know and just count out combinations. It's a very simple way to solve it. And for problems like this, I'll have an actual packet for them with all the problems in past AMCs that were related to the topic. But this is just a simple example of, okay, I know what I need to get, and I just need to count up the combinations. Yeah, and I just let the kids do it on their own, depending on how many students. Again, like Hrithik was saying, they could do it in groups, try to work together. It's a pretty simple problem, so I expect most of them to be able to solve this probably without any explanation. But yeah, and then I move more into specifics. So this is another problem with an example that I think kids will definitely like. It's pizza toppings. So starting with how many ways can you choose 2 distinct toppings? It'd be the same idea. People will be like, okay, I'm gonna pick one and I'm gonna pick the other, and then just count up the combinations. And eventually what they'll come to realize is, oh, for the first pizza topping, there's 9 different toppings I can choose. For the second one, there's 8 different toppings I can choose because I can't choose that previous one. And that starts to build the idea of, okay, what is a combination? How do I calculate the combination? So for this, I'd explain that, okay, you could pick a pepperoni first, and then what could another option be? And someone just say something. And eventually the kids themselves will come to the understanding that, okay, 9 times 8, 72. There's 72 different ways I can get toppings for this. And then I talk about order, like, does order matter or does order not matter? So if you just do 9 times 8, you'd be considering a scenario where you have a pepperoni and then an olive, or an olive and a pepperoni. So just small features like that is a very big slipping up, and where people make mistakes even on problem 5, problem 6. It's a major way that I want to just focus on, okay, how can I take this knowledge and apply it to AMC? And then once I've explained how to get 2 distinct toppings, I'd start with 3. So and I'd wait for them to work it out on their own, and then come together and explain how would you figure out 3 toppings you'd pick, and they'd get 2. Okay, it'd be 9 toppings for the first one, 8 toppings for the second one, 7 for the third one. 9 times 8 times 7. Then they would figure out, oh wait, but I have to divide by the probabilities that are the exact same. So whether you have pepperoni, olive, and mushroom, or pepperoni, mushroom, and olive, that's the same combination. You have to divide by, it would be 6, and they figured that out through, okay, how many different ways can I arrange 3 different topics? They'll eventually come to the idea, and that's the main point. And then I move on to just an explanation of combinations, a full, like, actual explanation, kind of dead dictionary definition, if you want to think of it like that, which would be that a combination is any way of arranging a group of objects in a way that order doesn't matter. So by this point, the kids would probably understand that, they'd get what that is. And then I'd move on to some basic notations. This is probably the least interesting slide of all, because notation isn't particularly interactive, but it's definitely important. And so I focus on the first one here, where you're talking about the specific notation of n choose r. For AMC 8, this isn't really a notation you'll see that often. You'll see it in solutions, but in the problems themselves, that notation isn't used too often. It's just useful for understanding, okay, what am I doing with a combination? How do I apply that combination to a problem? And then I'd have a couple practice problems for them on paper, obviously, to just write out if you have some toppings and you're choosing some, how would you write that? N choose R, so like 7 choose 3, how would I write that out? How would I say that? What does that mean? Just a couple of practice examples for them to do. And then a main point, particularly because it's an AMC class, is these ideas. So what will you see in an actual competition? You're never gonna see, oh, specifically for this problem, you must do 7 choose 3. That's not gonna show up. It's gonna say, out of 9 topics, you need 7 unique combinations or unique choices. It won't always say specifically, hey, this is what you're looking for. So key terms, choose, unique, exactly, some number of items are picked. You need to understand, okay, where am I looking for a combination? Where does order not matter, and where does order matter? Because when order matters, you're gonna have a lot more combinations, and that's gonna be a permutation rather than a combination itself. And then there's gonna be conditions, which I'm gonna talk about a little bit later, but a lot of the AMCA problems aren't gonna be straightforward. It's not gonna be just pick this from this available set. It'll have some conditions like I don't want tomatoes and onions or whatever. And I'm just gonna bring in the same concepts when the kids are actually there. And then moving on to factorials, when you're dealing with combinations, and then the day 2 lesson will be permutations, so it's also focusing on factorials, just gauging knowledge. I would just ask, what is a factorial? Some kids would know, some kids would have never seen a factorial, some kids know exactly what it is, and then just gauging knowledge. People will quickly understand what a factorial is, and I can explain it. It's a quick example, what a factorial is, and then I give a couple examples of like 3 factorial, 4 factorial, see if they can just work their way through understanding. It's not necessary for them to memorize it, they can calculate it pretty quickly. But yeah, just they understand that pretty quickly. And then I'd ask, what can you see with factorials that could have applications to combinations? And that's when they connect the ideas, right? Oh, in the first problem, we did 9 times 8 to figure out the number of combinations. How can I apply that here? Oh, well, it's 9 factorial divided by 7 factorial. And that idea is gonna keep coming through. They'll go through, okay, what about when I chose 3 pizza toppings? What was that? Oh, it was 9 factorial divided by 6 factorial. Oh wait, but then I also had to consider. And then they go through that process. I can help them along the way. It's just them trying to figure out, I would just prompt them by asking what factorials have to do with combinations and see how far they get. And eventually I'm going to talk about this. This is the very literal formula. It's a little bit more challenging to understand if you're 4th and 5th grade, but I can explain it in a way where the top is just your total number. It's if you picked everything, everything you have there. Obviously you're not picking everything, you're only picking a certain number. So that's why you divide by r factorial. That's n minus r factorial. That's the choices you don't make. So if you have 8 objects, you're not gonna pick 5 objects. You're gonna pick 3 only, right? So you can do all those 8 objects on the top, which is that 8 factorial, divided by the objects you don't pick, which is 5 factorial. And the ones you do pick, because you know order doesn't matter, the number of orders there would just be 3 factorial. So this idea, they're gonna get through pretty quickly, and if they don't understand it, I can explain it a little better with a more visual diagram. If I bring the balls, I can just show different organizations. And yeah, factorials are definitely really important. Some problems, not very many, but some problems actually have factorials in them. And there's an example here. This is one of the problems on AMC that's just factorials. So it's also an important concept to understand how they work. And I'd let them work through this also the same way. This would all be in a packet during the actual lesson, but I didn't print that out. So yeah, and then moving on, this would be a practice problem that I'd do together. If I had a whiteboard, I would probably do it on that. I'd figure out something to kind of draw and show them. They can work through it, and I have them guide me so they can show how much they understand. Particularly this problem has a lot of information that isn't strictly necessary, which is a lot of stuff that AMC8 does to throw you off. They'll include information, like they'll have word problems that are extremely long, and you need to figure out what exactly do I need to solve this problem, right? This is a pretty long problem. You can simplify this. If I wanted to write it quickly, I could write it in probably 6-7 words. Sorry. So it's not intense. But the point is you need to figure out the information that is necessary. And again, I hope the kids will try to figure out, they'll say, oh, the numbers that I actually want are, there are 8 students that signed up and I need to pick 3. I can figure that out based on what I know already. Yeah, they'd work through that problem. They'd guide me, figure out how much they know. And then I move on to some more complicated problems. Most of the AMC, again, before this, it's basic combinations. Like, that's not going to appear on your AMC8s. It might in 1 or 2 problems, as I showed before, but most of them are going to have some sort of conditions. So rather than just saying, I want to find out how many combinations, I want to find out how many combinations that have this specific thing or have these students. And just bringing it back to the previous slide, I would mention some conditions and then see what they think. Just get their ideas what are they thinking, what are they processing, how much do they already understand, how fast should I go? Just a lot of these lessons are built in a way that, depending on if they know a lot in a certain topic or very little, I can explain it more in depth or less in depth. And then based on their responses, I would move on to how a rule of thumb for, again, I think what's really important in AMC8s are rules of thumb, because if you get an answer, you want to be able to really quickly check, does this answer make sense? So generally, if you have a condition on top of a combination, you're going to have less probabilities, less combinations than if there was no condition. Just makes sense. It's a quick way to check your work. If you put in a condition and then you got more answers than there should have been, that means you probably did something wrong. So again, this is just going back to, they want to learn about AMC8, that's why they're taking the class. This is useful for AMC8, just competitive math in general. And this is a more specific problem on repetitions. So in all the previous problems, there were some keywords such as distinct, unique, whatever. Those keywords mean, like, if you had, say, 9 pizza toppings, like that problem, you can only pick one pizza topping once. So you have mushrooms, cheese, and pepperoni. You can't have pepperoni, pepperoni, and pepperoni. That's not a valid combination for that problem. Some of the AMC problems are going to have that as a valid combination. So for example, this one have different jelly bean flavors. If you pick one jelly bean, because you can consider an infinite amount of jelly beans per each flavor, you can pick 3 of the same flavor. That's a valid combination. And it's ideas like this. This problem, when you look at it compared to the other one, it's not, there's no specific word that's like, hey, this is gonna be, you can consider repetition. It's more, you understand the context of the problem and you notice the lack of keywords. So it doesn't say distinct combinations, or it doesn't say like how many, where you can only pick each jelly bean each time. It's not gonna say specific things. You have to focus on context and understand, okay, can I pick the same flavor twice? Can I not? And that's the main focus of this. This is a little bit of a simpler concept, but again, AMC8, that's what they want to learn. They want to learn how to solve these problems. And then this is just more general, be careful. Yeah, this is just more general, specifically, be careful, read the problem. That's a lot of it, especially young kids when they come and they're experienced with math. They'll be like, oh, I know exactly what I need to do, write the problem down, and they get it wrong because they miss a specific key detail. That's the main thing I want to focus on with this. And then last one is probabilities. These are definitely the more complex side of things. It's where you combine combinations and permutations. So this would probably be the end, if we have time, if the kids are truly understanding everything that I explained to this point, we get to probabilities, which is you combine, okay, how many combinations can I get with my conditions versus how many combinations are there total, and then you find probabilities. And here it's really important to, again, consider every condition, because a lot of times they're gonna give you more broader conditions, like probability you get exactly 2 reds. They're gonna give you conditions where you have to actually take all the knowledge you've gotten so far, plus a little bit more on permutations, which, and will be in day 2. So this slide could come today or on day 1 or day 2, depending on how well they understand, how well they get through stuff. And then probabilities, it's just that I'd explain it to them. And there's a kind of example problem at the bottom. See what are they thinking? Do they understand this? Do I need to explain it a little more? Should I wait till permutations? Just depending on how they understand it. And then at the end, these are just a bunch of practice problems. I would have them all in, again, a packet for them to understand. Some of these are easier, some of these are harder. So the problem's closer to the end. This is problem 25, so these are gonna be quite challenging. And then you're gonna get other problems like problem 7, problem 13, which are gonna be more simple. So depending on how well they understand, there's always gonna be problems that they can solve, they can attempt to solve. Yeah, that's the gist of it. I think what I definitely want to do with these is have them work in groups depending on how many people there are. It's going to be that lesson that I did with maybe a couple practice problems in between, and then the example problems that are within the slides themselves. And then these 7 problems, I think, that are at the end, they can work on in groups together. And then one thing that I really want to do for this one, because it's a very visual concept, probably bring a bag, or as I was talking about, multiple different balls. They can understand what a combination is. Depending on the weather, we could go outside and just have them pick out things and try to understand, okay, what combinations, how do I see that in the real world? Just for them to have fun with the concept, interact with it. But that's about it. These are just the practice problems, and I'll be in the practice. Okay, go ahead.
Yeah. Two questions. The first, I think you need some warm-up activities or introduce.
Yeah, that's what I was thinking. I kind of explained that at the end, but yeah, I'd bring in like balls of different colors or maybe marbles or something to get the idea of, okay, what is a unique combination versus what is a permutation?
Yeah. Second, I think perhaps you can ask some kids teach other kids so they can have the sense of achievement. I think yes. Yeah. Perhaps furthermore, perhaps you can ask some kids do their own problem for the other one or things. That's very interesting, I think.
Yeah, I think with some of the practice problems that are in there, like the AMC8 problems, I expect that probably depends on the percentages, but it could be like half of the class understands it pretty quickly, solves a problem, and the rest is like working through it, finding some difficulty. And in that case, I'd be exactly like you were saying. One of the kids would say, "Oh, here's how I solved it," and then they might be able to explain it in a way. They're peers, right? So they know how each other think a little better than I do, and they can explain it to each other. That might be depends on again how many students we have and how well they understand it.
I think four or five, yes. 4 or 5 students in AMC.
Hopefully,
Yeah, 4 or 5 should be good.
Yes, thank you.
Yeah, so I think just like a tip, I don't think you should give them all the problems in the beginning in like one packet, because then they might like there's always those like one kid who just does all the problems with it.
I think I'll probably have the packets on my desk or wherever, and then I'll give it out to them kind of when we're reaching the end. And I might keep it on separate papers so that I can just give one paper for one specific problem. Because I know there's definitely kids who are going to work through the whole thing and then do something else for the rest. So yeah.
And I know we said no homework, but like for this class, you might want to give them like extra problems in the packet and be like, you can do these at home if you want.
Yeah, that's fine.
Like there's always gonna be like some people who are better than the other. Well, you don't have, it's like optional.
Yeah, I think the problems, as I was talking about, the problems closer to the end of the AMC, so 23, 24, 25, those problems are pretty challenging, and I think I'll send them as like, hey, this is a combinations problem, but it's going to take a lot of time, or you might not fully understand it, and then those kids that are like, oh, I truly understand this, I want to do more, they can do this problem set.
Well, yeah, because you don't want.
I don't want to waste
run out
time.
You also don't want them to like run out of questions to do.
Exactly.
And every week you're doing a different topic, right?
Yeah, every week will be, or every week is a different category, and then each day is a different topic. So.
And maybe just a suggestion, like for the Monday of every week, begin the class. You could give them like a 30 minutes quiz.
Oh,
kind of cover
that's
everything.
I was thinking either the beginning of the next week or probably the end of the first week might work a little better, because otherwise the last week they won't have any quiz. So I was thinking the last 20 minutes or so I can just throw together some problems, see how much they understood, how much they didn't.
That works, but I actually talk about before you teach a class. So you kind of like they already passed the the qualification test, so they have a certain level. But
you mean placement test?
Yeah, placement test. I kind of see if they understand certain topics better than other topics.
Yeah, I think that'd probably be good. Depending on how much time we have, I could do a pre and then a post to see like how much they improve. But that might take up too much time. I might just do the ending. Yeah. That's a good idea.